Hello, and now we go to iteration number 5, and in this iteration we're going to calculate the score and display the statistics. Here is our action plan. We have almost all the parts of the game now working. We left with the score and the statistics, and we're going to complete that in this iteration. And that leaves us to iteration number 6, where we're going to do some enhancements, in particular enabling and disabling the buttons at the different states of the game. So again, we apply the app development process, problem formulation, solution implementation. In problem formulation, we start with the scope, and in the scope here to calculate and display the score, and to display the statistics screen and update the statistics in there. So how are we going to calculate the score? This is a decision you want to finalize, and either finalized by your client or by, if you're building the game yourself, so you finalize it. If you have someone giving you the idea, then you have to go back to them and say how you want to calculate the score. There are so many different ways to calculate the score. I'm gonna go with the easiest one here, but I want you to recognize that you can have the challenge of the game, the way to present the challenge to the user, and the way you collect the user feedback happen similarly, but you grade the user and calculate the score differently. I'm going to use this formula in front of you, number 1.2, the score equal the number of correct answers divided by the total number of turns multiplied by 100 to get a percentage. So my score is a percentage. Once you calculate the score, you're able to update the statistics in the game. And I'm going to focus on four statistics, four values: the highest to score ever, the lowest to score ever, the recent to score, and how many games were played. So the testing, we need to test for the correctness of the score and test for the correctness of the statistics. So we play the game with no correct answer, the score then should be 0. So we see and make sure it is 0. Play the game with all correct answers, so the score should be 100, and we should see 100, and then try one correct answer, two correct answers, and so on and so forth, and display the statistics and see the values in the statistics screen. Then we move to the solution formulation in the model, what data the app needs and how to present it. There are two additional data items needed for this part: the number of correct answers and the score. And the score can be float. It can also be integer. So if you have it can also be an integer, and it depends on what you want. Like if you have two correct answers over 3, you can calculate that as 60. You can calculate 66, or you can calculate it with decimal. I actually think we should calculate this as the score is a decimal, but we can present it as a non-decimal value, not really a decimal value. Or you may say, well, let me see how it's gonna go and even keep it decimal but cut out the decimal points. So we can look into that. View, displaying the score in the alert view and adding the statistics screen to the data in the label. In the solution formulation, we have multiple controllers, and within the same controller there are different states or different functions. So in the game controller, which is called view controller.swift, the main screen controller, we have 3 places where we need to make some changes. First, in the check answer, this is the function where we determine if the user's answer is correct or not. So if the answer is correct, then we need to update the correct answer counter. If the answer is not correct, then we don't have to do anything. Then we have the end game. When the game ends, we need to calculate and display the score. So we need to show the score in the dialog or the alert, and then we need to update the statistics. So in the updated statistics, we need to we just play the game. So we need to retrieve all the statistics from before and update it based on the most recent game that was played. Then we have another controller, the statistics screen controller. In that statistics screen controller, we just want to display all those statistics. So when the statistics view load, we need to display that statistics data, retrieve it and display it. So how are we going to retain the statistics over multiple games? We're gonna use, there are different ways to persist the data over multiple usages of the app. Um, some of it are on the device itself, some of it on a server away from the device, some of it in the memory of the device, which means that it will be there as long as the device is on, and once the device is shut down, the memory will be reset. And on the device itself, you can use files, you can use different types of files, and you can use databases as well. In the next module, we're going to learn how we can use a file and write data to a file and read it from a file. In this particular project, we're going to use a library provided and managed by the operating system that lives in the memory of the device. And that library is called the standard user defaults, NSUserDefaults. The operating system maintains an object that is a shareable object between the different screens in the app. And the way it works is, as you can see, the game screen is its own independent module, and we talked about this in module number 2. The game screen has its own data, has its own scope. So the statistics screen does not know anything about what's happening in the game screen. In the game screen, that's when the game is played, so that's when I know about the score, and that's when I can update the score. However, the statistics screen, that's where I want to show it to the user. So I need to move the data from the game screen to the statistics screen. And I could have thought of using module number 2, the segue, but the segue will mean that the game screen need to hold on that data in their own memory. I'm going to use the user default because the operating system holds on to the user default and manages the user default itself. The user default contains a table, a key value table, similar in concept to the one we used in module 3, the unit converter. The key value, the key is a name and the value is whatever value you want to give. So I will take my 4 statistics item and load them to the user default as keys with the value. So the game controller can then go to the user default, retrieve those 4 values, update them, and then write them again. And the statistics screen can then retrieve those values also from the user default and display them to the user. So that's the primary concept for the solution formulation. So how are we going to implement this? We're going to define an add count, correct answer counter, go to the check answer, the end game, the updated statistics, and this is end game, not play game, because I separated the end game from the play game. Calculate, display the score, and call the function to update the statistics. And in the updated statistics functions, I need to retrieve and update the statistics. And then there is another step here, which is the statistics screen. Statistics controller, and in the statistics controller we need to retrieve the statistics, and display the statistics to the user. And then we run the app and test it, and that will complete the iteration number 5. And at the end of this iteration, that's the required part of the project. The next iteration, iteration 6, will be enhancements, and this will be considered extra credit. So thank you.